Hello, Algebra 2 Honors. Welcome back to our second video in section 6.2. We are going to be learning the fundamental identities. There's going to be quite a few, so we're going to get right into them. The first set of identities, we have a name for them. We call them the reciprocal identities. You'll see why they're called the reciprocal identities. We briefly talked about this near the end of the last video. We defined cosecant theta to be the reciprocal of sine. If you remember, the trick there was you look at the first letters, and they should be different. Secant of theta will be the reciprocal of cosine. And then cotangent of theta would be the reciprocal of tangent of theta. Right, so these are your three reciprocal identities. We briefly talked about where those came from. Let's go into our next set of identities. We call these the quotient identities. You'll see once again where they get their names from. So one of the quotient identities is tangent of theta, which is equal to sine theta over cosine theta. I'm going to give you a very short informal proof as to why this is true. If you guys remember SOHCAHTOA, right? If I have sine theta over cosine theta, sine will be opposite over hypotenuse. Cosine would be the adjacent over the hypotenuse. And this is the same thing as taking the numerator and dividing it by the denominator. But this, you can think of it as opposite over hypotenuse multiplied by the hypotenuse over the adjacent. Here, the hypotenuses will reduce each other out, and you're left with opposite over adjacent, which we know is your tangent, right? That's the TOA. And so this is one of your quotient identities, right? The tangent of theta is the same thing as sine theta over cosine theta. You have another one for cotangent theta, which, because we said cotangent's the reciprocal of tangent, that would mean that cotangent theta would just be cosine theta over sine theta. And those are your two quotient identities. So we're going to look at a couple of examples where we get a chance to practice using these identities to find the trig functions of theta. So let's go right into our first example. Here they're going to give us some information. Sine theta is root 3 over 2. Cosine of theta is 1/2. And what we're going to do is we're going to find the value of the remaining four trig functions of theta. So given sine theta and cosine theta, can we find the other four? And so what I'm going to do is I'm going to actually write down what's already given. So I already know that sine of theta is given by that. I know cosine of theta is given by that. I'm going to next find tangent of theta. Tangent of theta is sine theta over cosine theta, right? Using our quotient identities. Sine theta is root 3 over 2. Cosine of theta is 1/2. Here we have root 3 over 2, right? The numerator divided by the denominator, which we know that's the same thing as saying root 3 over 2 is multiplied by 2 over 1. The 2's will reduce, and I'm left with root 3, and that is tangent of theta. Once you find those three, I think that's the hard part, because to find the rest, we're just going to take the reciprocals, right? So for example, if I want to find cosecant of theta, I know that's the reciprocal of sine theta, right? And so I know I can just take 2 over rad 3, because all I'm doing is I'm taking this, and I'm just taking the reciprocal, right? But then, if you guys remember, we have to rationalize the denominator. So to do that, we're going to multiply the top and bottom by rad 3. And what happens is I'll get 2 rad 3 on top, and on bottom I get 3. and this is the cosecant of theta. Now from cosecant of theta, I'm going to find secant of theta. And once again, secant is just the reciprocal of cosine. So what I'm going to do here is I'm going to look at the cosine value, which is just 1/2, right? And so if I take the reciprocal of 1/2, I just get 2/1, or just 2. And lastly, I'm going to find cotangent of theta. Here I'm just going to use the fact that cotangent of theta is 1/tangent of theta. And that would just be the reciprocal of this value here. And the reciprocal of that would be 1/rad3. Once again, you want to rationalize the denominator, and you'll get rad3/3. Now, if you noticed, when I found cotangent of theta, I didn't do cosine over sine. But what I want you to notice is if I had done cosine over sine instead, you'd actually get the same answer, right? Cosine of theta we said was 1/2. Sine of theta is √3/2. This is the same thing as saying it's 1/2 multiplied by the reciprocal of the bottom. The 2's will reduce. You're left with 1/rad3. If you rationalize, you actually get the same thing, right? So the thing is, there's so many different ways you can get these answers, and you want to be very comfortable with all of these various trig identities and know how to use them well, okay? And so we found all 6 trig values when they only gave me sine and cosine of theta. I hope that makes sense, right? How we use the reciprocal identities and the quotient identities. Now, let's try another example. And it's going to be very similar. Here, they gave me sine of theta, which is 1/3. And they also gave me cosine of theta, which is 2rad2/3. Just like we've been doing before, when the video says your turn, I want you to press pause and I want you to try this out. I want you to find the remaining 4 trig functions of theta. So here I'm going to do it in a different order. This time I'm going to find cosecant first, because I know cosecant of theta is a reciprocal of 1/sine theta. So if I know sine is 1/3, I know cosecant of theta would just be 3/1, or just 3. Next, I would find secant of theta. If cosine of theta is 2rad2/3, I know secant of theta is just the reciprocal, right, which is 3/2rad2. But again, you want to rationalize your denominator. Multiply the top and bottom by rad2, and you'll get 3rad2/4. Now from here, I'm going to find tangent of theta. And to find tangent of theta, I'm going to use my quotient identity, sine over cosine. Sine theta is 1/3. Cosine of theta is 2rad2/3. And just like we did before, this is the same thing as taking the numerator and dividing it by the denominator. Or you can just multiply by the reciprocal of the denominator. Here the 3's will reduce. I'm left with 1/2rad2. But once again, hopefully you rationalized your answer. And when you do, you should get √2/4. And let's squeeze in cotangent theta here. Cotangent theta would just be the reciprocal of tangent of theta, right? So if tangent of theta is √2/4, I know cotangent theta is just 4/2. Once again, you want to rationalize by multiplying the top and bottom by rad2. Here we'll get 4rad2/2. But then I can go one more step because I can divide 4 and 2 here. And if I do, I'll end up with 2rad2. And this would be what cotangent of theta equals. Hopefully you were able to get those problems correct. If you made any mistakes, again, make note of what you did wrong and make sure you learn from them. So far we talked about the reciprocal identities, we talked about the quotient identities. There's one more set of identities that we need to go over, and those are called your Pythagorean identities. So for the Pythagorean identities, there's actually only 3 of them, and we're going to actually derive them all. So what we're going to do is we're going to draw a right triangle. I'm going to label this acute angle here theta. I'm going to label the sides A, B, and C. If you remember, we talked about the Pythagorean Theorem earlier, which says that for any given right triangle, we know that the sides of the triangle will always satisfy this equation, where C has to be the hypotenuse. Taking this equation, I'm going to divide everything by C squared. Now from here, I can rewrite this as a squared over c squared plus b squared over c squared equals c squared divided by c squared is just 1. I can go a step further and rewrite this as a over c squared plus b over c squared equals 1. So looking at this right triangle, I notice that sine of theta equals opposite over hypotenuse, a over c. And I know cosine of theta, which is adjacent over hypotenuse, is b over c. So what I can do is I can take sine theta, which equals a over c, and I notice there's an a over c here. So if I make that substitution, I end up with sine theta squared plus, and doing something very similar here, I know that cosine of theta is b over c, and I see a b over c here. So I can make that substitution, and I'll get cosine of theta squared equals 1. Now the way we typically rewrite this though, is we write it as sine squared theta plus cosine squared theta. And this would be your Pythagorean identity. This is one of the Pythagorean identities, actually. This is your first one. And so the one thing to note is that when we write something like sine squared theta, what that really means is that's sine theta times sine theta, okay? Which you can also write it like this if you want, but typically this is the way you're going to write sine squared of theta, okay? And so taking that first Pythagorean identity, we're going to use that to come up with the other two. So let me rewrite sine squared theta plus cosine squared theta equals 1. And the trick here is we're going to take this equation and divide everything by cosine squared. Now, here I'm going to rewrite this as sine theta over cosine of theta squared plus cosine squared theta divided by cosine squared theta is just 1 equals, and this I can just write it as 1 over cosine of theta squared, okay? Now, if you remember your identities, right? Tangent of theta is sine theta over cosine theta. And if you remember what 1 over cosine is, that's the secant of theta. So you want to make sure you know your identities well, because when you see them, you want to be able to recognize and use them, right? So going back to our equation, right? I know that sine over cosine is tangent of theta, right? And looking at our equation so far, I have sine over cosine. So once again, we're going to make that substitution. You'll get tan squared theta plus 1 equals, and doing the same thing here where we're going to take secant of theta, which is 1 over cosine of theta, and I see a 1 over cosine theta there. Make that substitution, I'll get secant squared of theta. And this is my second Pythagorean identity. There's still one more to go. What I'm going to do next is I'm going to take that Pythagorean identity again, the very first one that we derived. And you remember how I divided everything by cosine squared of theta? This time I'm going to divide everything by sine squared of theta. Sine squared divided by sine squared is just 1. Plus, this would just be cotangent squared. And this is going to equal cosecant squared. And this would be your third identity. If you're wondering how I got that, well, I'm using the quotient identity that says that cotangent of theta is cosine of theta over sine of theta. And then I know that cosecant of theta is 1 over sine of theta, right? And so these are your identities that you want to know well, okay? So I'm going to quickly just write down all the identities we just talked about right now, because there were a lot. And these are going to be your fundamental identities. So we first did the reciprocal identities, right? Which said that cosecant of theta is 1 over sine theta. We said that secant of theta is 1 over cosine theta. And then we said that cotangent of theta is 1 over tangent theta, right? Then we talked about the quotient identities, right? Where we know that tangent of theta is simply sine theta over cosine theta. We also said that cotangent of theta is cosine theta over sine theta. And then we just derive the three Pythagorean identities, right? Sine squared theta plus cosine squared of theta equals 1. I'm just going to line these up right here. We also came up with the fact that tangent squared of theta plus 1 equals to secant squared of theta. And then 1 plus cotangent squared of theta is equal to cosecant squared of theta. Make sure you look at all these formulas again. Make sure you understand where they come from. And then in the next video, we're going to look at a couple of examples of how we can use these fundamental identities to find the trig values of angle theta.